Yeah. Dave, I've got feedback here, the two laptops are chatting. So if I turn the sound down on this one.
Yeah.
Okay, we're unmuted, I think.
And your video was, we just checked as well, see that statement lines.
The video.
There we go.
Okay, so few technical issues. We're here and back again. I'll just recap a quick bit thing for those people online that perhaps didn't hear me. My name is Steve Horsley. I'm the sales director of a company called SERTEC, and we're going to talk about deionization, lightning protection technology. I'm a member of the Institute of Engineering and Technology, IEEE, SIGRE, and I know there's some gentlemen here from Ireland. I represent the National Standards Authority Ireland for lightning protection. So we are very, very involved in all of the technical organizations. We're very happy to be here with the IIMS, and we're spreading the word of this technology very much so. So let me just move on to the next slide, if it will let me do it. Nope. Oh yeah, there we go. Let me just move us all out the way. So SERTEC is founded in 2001. I actually found them during COVID. I was on LinkedIn, and this president, Mr. Amanda Schifferelli, posted that we have a technology that does not allow a lightning strike to occur in a protected area. And from my engineering background, I was very fascinated, twiddling my thumbs at home when we were all sitting there in COVID. And long story short, 6 months later, I ended up running the region for them. The company is an award-winning company. They're based in Paraguay, South America. South America is a tremendous amount of lightning in there. And they've been dominant through Southern Americas and also Northern America. And I help them now develop the business in Europe, Middle East, Africa, and the Asia markets. We have about 100 employees, and we have over 2,000 installations worldwide. So let's look at what the lightning process is. It comes from a cloud called a cumulonimbus cloud. I'm sure everybody in the room knows all of this. It's the biggest cloud that we have in the atmosphere, and it's caused by a lot of turbulence through hot air and cold air. It operates within what is called the troposphere. The troposphere actually goes up. It's our first layer in our atmosphere. It goes to about 11 to 12 miles high, 18 to 20 kilometers. And this is where normally all of our weather occurs. And above that, we have the stratosphere, mesosphere, thermosphere, exosphere, and the edge of space. What we see above cumulonimbus clouds is another aspect of lightning. These are called red sprites, blue jets, and elves, and these are all called transient luminous events. They don't really affect us at all because they're too far up in the atmosphere. So what happens in the cumulonimbus cloud and why we have lightning is because charges get separated. And we'll see this in a video in a moment, where atoms, molecules lose an electron from the outside of that atom or bunch of molecules, and they become what is known as ionized. And they have a technical term for them. A cation is a positive charged atom or molecule, and an anion is a negative charge. So what happens when these charges split? They get moved apart within the cloud, and under the basics of electrical law, all they want to do is to come back together again and neutralize themselves, and that is what the lightning strike is. So what we get also is that on the ground, when the cloud comes across, it becomes heavily negative charged. And it's really just looking for a buildup of positive charge, whether, of course, with the marine today on the sea or whether it's on land. And so it's a bit like magnets. When you held magnets, if you put opposite charges together, they come together very quickly. If you put similar charges together, they push apart. You just cannot put them together. So when the cloud comes across, and it's mainly negative charged, the ground pushes all the negative, or the sea pushes all the negative charge further down into the land or into the sea, and positive charge starts to get attracted and rises. So if you're on your boat starts to become ionized. And so that will definitely happen. The boat will become ionized. And it depends on whether the boat is ionized to the extent that it is the biggest attraction for the opposite charge. So, as I say, it goes to the area of greatest attraction. So if you look at where lightning strikes, we don't know where that is because we can't physically measure it, but it is where the buildup of charge is the greatest. When a strike occurs, and you're going to see this in some examples in a moment, there is a thing called a return stroke. The lightning channel, which is a plasma channel, flashes, and that means that this charge is going up and down in the same channel. So you may not just have one discharge, you can have multiple discharges. So it becomes even more exceptionally dangerous. So if you study lightning, it's called fulminology. If you're frightened of lightning, it's called astrophobia. It comes from the cumulonimbus cloud, as I mentioned. And if you've ever heard of the term, being on cloud 9, this is where that comes from. And there are other statements about being on cloud 9 as well, but generally that's where it comes from. It's creating this electrical and electromagnetic field in the atmosphere. It's pretty significant because of charge separation. And there are different types of lightning. We see the flashes in the atmosphere within these cumulonimbus clouds. They can be within a cloud, it's called intracloud. It can be cloud to cloud, which is CC. It can be the dangerous one for us, or the next two, cloud to the ground or ground to cloud. So lightning can actually go upwards as well as downwards. So, and we can see examples. There's many examples on YouTube that you can see. Of course, we know thunder, and the gentleman earlier was talking about lightning, which was quite nice, and the speed of sound and the speed of light and all of those things that we know. And it's not a good rule nowadays to say it's 5 miles away, I'm safe. You're not. If there's a storm in the vicinity and you're 5-10 miles away, you're still not safe. And I'll explain that in a moment. Mike explained how many lightning strikes a day. We talked about it. 44 to 100 lightning strikes every single second. So while we've been talking, there's been thousands of discharges starting to occur, and it's around about 3 billion a year. And what we've seen, all of us have seen with the atmospheric conditions this year, is that weather storms are getting more fierce, changing. It's a period in the world which we see more lightning storms. So how lightning gets to its next point is through a thing called a step leader. Lightning is not just one straight line. It goes in steps. So it will go in a step, it will ionize the atmosphere, it will get another ionize, it go another ionize, and we see this branching out of lightning coming down, searching for the buildup of opposite charge. They travel roughly, and it can be more or less 50 to 150 meters at a time, extremely fast. So it looks like it's one strike or it's one jaggedy line. What happens is, though, and I'm not sure how many of you know this, but with lightning, actually, it doesn't just hit the ground, the boat, the sea, or whatever. There is a thing called an upward streamer. That is the buildup of opposite charge coming off of the land or coming off of the sea, and it comes up to meet this downward charge, and they meet not on the ground or the sea, they meet in the atmosphere, and that can be a certain distance away. It brings with it a lot of trouble. Whilst it's phenomenal to watch, and I'm sure everybody in the room's seen it, lightning is 300 million volts, plus, can be a billion, 30,000 amps, and it's 30,000 degrees of temperature, which has been measured by probes that are, well, not probes, thermal imaging type stuff. It goes 270,000 miles an hour. It lasts for 30 microseconds, and discharges can happen extremely fast, and there can be many of them. It creates a very small level of ozone, and if after a big storm you don't have to necessarily have lightning, there is a thing called petrichor, and petrichor is that wonderful smell that you can hear with fresh rain and all the storm afterwards. So that's not really the lightning doing that, it's more of the heavy rain. Let's just look at lightning just quickly. We have to, we're talking about lightning. Oh, let's go back and run this video. What we're seeing now is the craziness of lightning. So we've got the volume turned off, but it's okay. You don't need to hear the bangs and crashes. But this is time-lapse video. And what we're seeing here is with the lightning that we've got this intra-cloud lightning, these strikes that are going through the atmosphere. And then what you'll see is the odd strike that goes downwards. This is the cloud to ground, or it's the sea. And so we have a tremendous amount of different activity. And you have to wonder, how could you protect something from that immense force? And so we'll talk about that as well. So how likely are you to be struck by lightning? Let me just ask all of you experts here, do you know someone that's had a boat hit by lightning? Yep, hand up, anyone? Right, so it's most people, okay? So over 75%. Because we're in lightning, we hear about it every day. We hear about boats all over the world being struck by lightning. You know, it's the unfortunate thing is some people do lose their lives from it. What you see with these sailing yachts here is all of these masts sticking up. Now, these are massive attraction for lightning. Every single one of these masts gets ionized with the opposite charge. So it is ionized positive if the cloud is negative. And so any one of those yachts could be the major attraction for the lightning strike. And so that is what is a major attraction. According to insurance data, and there's not a tremendous amount of it that we can see, sailboats and catamarans, because of their surface area, are about 155% greater chance of being struck by lightning than, say, powerboats. According to boat.com, long-distance cruising sailboats can be hit maybe once in its lifetime. If you're cruising the seas all the time, you never know. Because they're bigger, they're off the water, they're at sea. And if you imagine you're at sea, you are the biggest thing that's out there, no matter what size you are. So your ionization is becoming great. So let's just look quickly at this little video. I don't know how many of you have seen it. This is in Boston Harbor. I've took out the reaction from the crowd listening, but this should play. Yeah. So there we see, the sky looks grey. It doesn't look particularly stormy, but that was a lightning strike that occurred on that particular sailing yacht. Now, why didn't it hit the one that was further out? You can see one further out there. You can see this mast here. That just happened to be the most ionized thing in the area. So quite a significant thing. So our technology, which we have been selling now for the last 20 plus years, covers every type of marine application. It covers, I don't know if you know silent yachts. If you guys have heard of silent yachts, they're a solar powered yacht company, very, very successful through our distributor here, Technical Marine Supply. Sorry, Nick, I didn't introduce you at the beginning. Nick is from our distributor in the UK and covering Europe for us, and can help with any other questions as well. So we cover basic sailing yachts and every type of yacht. We cover workboats, we cover offshore oil platforms, and we cover you know, any type of other type of application that's on the sea. It could be a marine buoy. We also protect marinas. We also protect the sheds that boats are built in. So it's all to do with electron movement. So if we're going to solve this problem of protecting, we have to understand in depth what lightning is, and atmospheric ionization. And when the cloud, various processes can cause the separation of positive and negative charges. And one of these processes, a new word, you may already know this word, is called triboelectric charging in the atmosphere. So this triboelectric charging is what is going on when a storm is around. Basically, ice crystals and water droplets in this immense turbulence within the cloud is actually transferring electrons between each other and knocking them out of balance. And so this creates charges of opposite charge within the cloud, on the ground, on the sea, and we have this imbalance, which is what gives lightning. So we have a little video here, and we break it right down to an atom now. So now we know an atom or a bunch of molecules. What does it look like? So let's just run this video. And what you see as it comes up is let's just take a typical oxygen atom. And this oxygen atom here, there's two oxygen atoms. Now you'll see a light blue electron flying out in a moment from the one on the right. It should be coming now. There it is. And that actual electron has now joined onto the molecule or the atom on the left. And what's happened is it's made that atom and molecule out of balance. It's not neutral. And when that happens, when you have more electrons on an atom or molecule, it becomes a term called anon. So it's negative. And then on the right-hand side, it's lost an electron. And so what happens is it becomes what is called a cation. And so in this video, it's just showing you right down to the very basics of an atom in the atmosphere. And of course, there's billions and trillions of them. And they're all doing the same thing. And these charges move apart, and all they want to do is to come back together. Let's look at how that's operating now. Let's assume it's the sea down below. This video just happens to be above land, but it's exactly the same. And what we see now is charges are now moving apart within this cumulonimbus cloud. And under electrical law, as I said before, all they want to do is to come back together and neutralize themselves. The electromagnetic field, this magnetic effect is bringing them back. But these high-speed cameras have caught these, these step leaders, these ionized plasma channels as they go through the atmosphere, being attracted to this charge. And again, the route that it takes is incredibly unpredictable. It can be absolutely anywhere. Sometimes you see it looping back on itself as well. So now we get to the one that is the dangerous one. If you imagine that being the sea below or the land below, we now have this discharge that is coming from the cloud because it's being attracted by charge buildup. And in the video, what we're seeing now is that the charge buildup is occurring. You start to see these pockets of positive charge that are now starting to come off the ground or off a boat or off the sea and connect. So this is where we get the two ionized charges meeting and the strike occurring. And what you will see in a moment's time is that you'll see the flash, and you'll see that the discharge of electrons are being drained, and that particular channel comes back to a natural state, and it's not at risk anymore. But on the left of the picture, what you see is this little point that's up. There'll be an arrow. Now, that's one that didn't make it. And there's another one here on a building. There's one off the top, very difficult to see. On the telegraph post, you can see it. And if you ever see anybody, you won't see it with me, with their hair going up in the storm, please take cover or go somewhere, because that is you being ionized. And people, unfortunately, do lose their lives. You probably haven't seen it, but a couple about 3 or 4 weeks ago on a Mexico beach were walking nowhere near the storm, got struck by a lightning strike, and that was that. The flashes that you see there are these return strokes. We spoke about, the speed of sound, speed of light, and all of that, and we all know those sort of things. So we know the damage that it causes. It causes absolutely tremendous damage. It can completely ride off a boat, and it can put people's lives at risk. If you're a charter company and you lose one of your yachts, you've lost all of the income and so on. So this was a recording at Seaworks. This is the one that Mike was referring to earlier. And it's just tremendous to see just how many discharges there are in a lightning storm. What you see off of Sardinia here, just south of Corsica and off of the coasts of Italy, is this storm records 4,200 discharges in the white bit in the middle there, which are the recent discharges. What you're seeing is these flashes are a recording of what I did at Seaworks. And you can hear the clicks, and the clicks are just all the time when it's happening. So we have that. Now, this is today. I did this sitting over there. Same island, just happens to be my island for lightning, it seems. But in between Sardinia and Italy, this tremendous storm is occurring right now as we speak. It's in the sea. So if you're a boat anywhere in that region, probably you've been warned of the storm, I'm sure, with all the onboard technology, but you're at risk. One thing to note about lightning is it does not have to be just in the storm. I don't know if I can put a pointer on here. I think I can. Yep, let me put my pointer on. What you see up here is one strike that is way outside of the storm. So the meaning is if a storm is near you and you think it's a long way away, you still not may be safe, because for some reason in the sea just there was a buildup of opposite charge. And then we all know that there are certain areas of the world where lightning is more predominant, but we see it come across the UK quite regular. We've had some immense storms in the last year in the Channel as well. I think we had one with about 30,000 discharges recently across the whole of the Midlands and everywhere. But what we see on this particular one here is, if I do it, this is obviously in the Gulf of Mexico, America, Florida. We know it's one of the lightning capitals of the world. But you just see the sheer level of storms that are across the whole of this area. And you see, again, these random strikes that are just not in the main cloud. When you go deeper into looking at the lightning map, what you see here is the white on the top left here is the recent strikes. They're within 10 minutes. Yellow is 10 minutes onwards. Red is probably a half an hour. And then the counter on the bottom left here, you can just see how many in that particular circle. This is between, as you see, Ireland and the UK and Wales. And then when you go straight into somewhere near where I live, where I was looking very closely when we had this storm, luckily, nothing came near my house, but you can see it's very random. We just don't know where they're going to be. So let's talk now about how do you take this technology and protect your boat, your asset that's on the sea. CMCE stands for Compensator Multiple de Campo Electroatmosférico. The reason it's in Spanish is Paraguay is a Spanish-speaking country. Now, we have fantastic history with this. One of the most brilliant minds in electrical law, Mr. Nikola Tesla, founded this technology way back in 1916. He said it is extremely dangerous for you to do a thing called the lightning arrestor, which was invented by Benjamin Franklin back in 1752, well over 250 years ago, that just put a metal point up, allowed it to become ionized, and because it was so ionized, it would attract the lightning strike to it. Now, you don't want that on your super yacht. You do not want that on your building or your home or a school. So Nikola Tesla invented a thing called a PDCE. You can see the shape of it. He used a capacitive technology to capture the excess charge in the atmosphere and drain it to the ground or the sea, which is ground. And what that does is it does not allow the buildup of charge. And the wonderful thing about his technology was it requires no power. It runs on nature. This technology of capacitors just runs on actually having the technology at the highest point, having an earth lead down into the ground, grounding it correctly on the boat or whatever vessel it may be, grounding it correctly, and you start to see this incredible thing, this electrical current drainage. If you use a clamp meter around this earth cable going down, and you'll see a reading. And there's another incredible thing, it's milliamps. It's not dangerous. We're taking all of this immense power from the atmosphere, we're draining it to earth and making that protected area non-ionized. It actually does a thing, which is on the first slide, called deionization. So we have a very rich history. So as a company, we are, as you heard me say at the beginning, involved in every standards type thing that we can for lightning, because it's very important. And so about 18 months ago, we went to the very famous Nikola Tesla Institute's high voltage lab. We, out of respect to Nikola Tesla, we said, can we show you the technology we've advanced? Because his patent ran out in the 1930s. And we took our technology, we tested it fully, and they wrote this report, study number 322053, and confirms that our technology does not allow a lightning strike to occur. And so you do not get this thing called the upstreamer. So, so how does it work? How does this operation principle work? So opposite charges attract each other, basics of electrical law. And we have a device here which is split into two halves by a dielectric plate in between. The top half is a capacitor, the bottom half is a capacitor, and it works under Ohm's law. And what it does is these capacitors are always drawing, these are very specialist type capacitors. These are not your off-the-shelf capacitor. These are ones that we've designed. So outside of the device, the atmosphere is saturated in negative charge and there is positive charge on the ground. And so what happens inside of the device, these two opposite charges get brought together very safely. It's not like a lightning strike. They're just compensating them. It's the English word for this is a multi-compensator of the electrical field. And you can see that it actually drains it down to the ground. In step 3, these charges are going to the ground. So graphically, we can look at it like this. We can see that these charges are being absorbed in 360 degrees directions. The lower disc connects to the ground, producing the deformation of the surrounding electric field that increases its coverage. So the devices that I'm going to show you have this, a bit like a car engine, a 1 liter, a 2 liter, 5 liter. So each of the devices has a greater drainage capacity. And that drainage capacity allows you to bring more charge from a different area in the atmosphere. So the functionality test that we do, so how do we prove this works? Remember, we've been doing this 21 years. Is that we use an artificial cloud in the biggest laboratories in the world, and we put our device underneath it, and these are impulse generated clouds. So we step up the voltage in the cloud, we put our device underneath, but first of all, we do all of these tests with a Franklin rod at exactly the same height, exactly the same distance. We step up the voltage until the air breakdown resistance occurs. And that breakdown occurs from the cloud down to the Franklin rod, there is a discharge. We put our CMCE there, all the same tests, there is no discharge. And the laboratories say, well, what's happened? Well, we say we've deionized the atmosphere. There is no buildup of charge. You do not get a lightning strike. And again, this device requires no power. This is me with a hard hat on. A little while ago, I was in Saudi Arabia about 4 weeks ago. We went to one of the biggest laboratories in the world. They can actually generate up to 3 million volts of impulsed energy in a cloud above. For this particular test and the time we had, we went up to over 500,000. And you can see a lot of our devices there. They're exceptionally well built. We have one here, which Nick has kindly brought down. It's our smallest device, and we have a condition monitor. So the test report fully proved, again, in one of the biggest laboratories in the world, no discharge occurs. And what you see on here is the program voltage, the amps measured, and these zeros means that every time the voltage was increased, there was no discharge. So there's lots of technical documents, lots of information that we can share. We also have internal tests. Every device that comes out of our factory, we design and manufacture everything in Paraguay. Every device is tested and fully certified when it goes out. So me being an engineer, first question I asked 3.5 years ago when I joined is, how do you know it works? You've put this device on the top of your boat and you've earthed it, and you've taken a clamp meter, you've taken a measurement, great, you walk away, but how do you know tomorrow it works? Because somebody could disturb the earth. And if you have no earth protection, you have no protection. So we came out 2 years ago with a thing called Storm 7. What it is, it's the accessory, it's the black box that you see there, and you're very welcome to look at it today. Basically, the earth lead goes straight through the black box, and it measures the electrical current drainage. It gives you real-time data, and as you can see on the laptop here, you can have it on your laptop or your mobile phone, and you can actually see that you have lightning protection. Traditional technologies do not give you that. So whatever traditional technology is on the boat today, you don't see that. So it measures the electrical current drainage in real time. It measures temperature, atmospheric pressure, humidity, height above sea level, or generally it's sea level in the boating world. And of course it is. And it also measures battery usage and everything else. So this is the device, very simplistic device, but it gives the captain of the ship knowledge that he is protected from lightning strikes. So real-time data and a lot of information that you can gather. And we have lots of live examples of this. There are a lot of installation guides. I'm not going to go into installation today. It would take far too long. But basically, there are calculations that we do that tell you which device that you should put onto your boat, how you should earth it, where the earthing should be, how many earthing plates you might need. Can you use the existing earthing? We have an expert technical team that work with our experts at Technical Marine Supplies, and we can advise you exactly what to do and take all of that hard work away. Because every project that SERTEC does, we are involved in. You cannot have the lightning protection on board of the boat without us saying, tick, it's correct, because it's lightning protection. Same for motorboats and super yachts and everything. So we have all of that. So there is a range of products. I'll just go through these for time quickly. You can see the quality of the products. They are all sealed so that they do not get affected. They're used with materials that do not get affected by salt. And so therefore, these devices are obviously should be environmentally protected. We have the gold, the platinum and diamond. They all weigh different weights. They all do different things. The gold, I would say, is for small sailing boats, you know, marine buoys, smaller objects. It protects a 25-meter radius. The platinum, much bigger. We're into the catamarans now, bigger ships. That's 55 meters. And then the biggest one that we do, which we put on super yachts, is the diamond, and that protects a 120-meter radius. And how do we give you the confidence that it protects that? Well, all of our test reports have done all of the protection areas. So certifications, we are going to be at METS next week. Myself, I'm with the Technical Marine Supplies. If any of you are at METS, we're in Hall 1773. And we're very pleased to announce with all of these, the bottom right-hand corner here, we are currently in classification approval with RENA. RENA will have the classification, fingers crossed, by December, maybe first week of January, but we are very close to being fully classified as the lightning protecting technology for marine applications, whatever that marine application may be. Lots of backup documentation if you want to read it. There's tremendous amount of information from the company. The installation guide, the brochures, Technical Marine Supplies technical team can certainly help you with all of that. And then let's just finish off my presentation today by saying that we have a lot of success stories. SERTEC started protecting everything on the land. But then we realized that the marine industry really needed this technology. So 3 years ago, we started installing on a lot of different boats. I mean, the first thing is, when you're building a boat, does it really work? How do you prove it? And all of that, we've gone through all of that. So silent yachts that you see here, it's just under the video symbol there, but just above there is a CMCE. So we protect that silent yacht completely, and with Technical Marine Supplies are supplying them the product. Here's some other ones that we've installed on all of these. So M5, one of the biggest sailing yachts in the world. I think it's in the top 10 still. I know there's a few bigger ones that are out there now. They're just about to upgrade their system with us. We have a stronger draining capacity, so we are on M5. Silent yachts, we've said, we're on lots of catamarans. Bottom left-hand corner, this is a yacht called Infinite Jest. We're on Infinite Jest. Liquid natural gas we protect, cargo ships we protect, and you can see on the right-hand picture here just how these are done. And you can see on this catamaran that it's the highest point, and so on. One thing I haven't mentioned is this technology does not interfere with any radar signal or any signals at all. So when you saw an Infinite Jest that we put it on there with all its huge radar that it's got, it doesn't affect it at all. So it's completely safe from any signals. This is something we're very proud of. You may have seen it. Hopefully it will play. I can't see the start thing for it. Oh no. Okay, I don't know if you've seen it. Sorry, I don't have the video start on there for some reason, but I can share it with anybody later. You may have seen that the cargo ship world is changing. Bar Technologies in the UK and Yara Marine now are putting wind wings onto big cargo ships. These are huge wings, metal wings that go up. And we're very proud to say that we are protecting Pictus, which is a big cargo ship with these wind wings on. And they've trusted our technology and put it on board, because these wings being so high are going to be absolute magnets for lightning. This is not marine, but it's just to give you the confidence. We protect petrochemical industries because you cannot have a spark coming to a petrochemical tank. Corporate buildings, normally you have multiple Franklin rods. We have just one device. I said it doesn't interfere with radar. We protect airports. Today, very good news, I found out we're just about to protect Manila Airport. We are going to we protect multiple airports around the world. So Manila Airport are going to put 45 of our devices on to protect the whole airport in the Philippines. We protect football stadiums, renewable energy. We protect some of the biggest companies in the world, Ford, Coca-Cola. We've just won a project as well yesterday for Aramco. Aramco are moving to our technology. We protect mines because mines, you have to close a mine if there's lightning around. The lightning strike to the ground could collapse it. Military bases and AES generation. But that's really just today to keep on track with time. This is a fully proven technology, and it is worth considering installing it on any type of vessel for safety. Because whilst it might be a figure of 5 in 1,000 that get hit, you don't want to be the 5. And really, because we're doing it every day, we hear every day of the difficult stories of somebody being hit with lightning. As you saw by the Blitzorg.org, it's not .com.org if you want to see that website. You can see that there are many discharges in one storm. So Mike, thank you for everybody. Open to questions from Zoom or from anyone here. Yes, sir. Well, that you have to speak to my expert on cost there. What Clark he'll give you. I mean, in fairness, he's our distributor, so you're here together, so he can chat and give you a good idea of the technology cost. Your technology cost is that this technology, once it's there, is a permanent thing. Now, there is one big advantage, and I think there's somebody on insurance this afternoon. We've been talking to the big insurance companies of the world, like Pantaneas, Admiral Insurance, Lloyd's in Hong Kong. We've been talking to. What they are saying now is that lightning is such a massive problem in claims that you can potentially have an advantage in your insurance premium if our technology is on board. And without naming one super yacht company here in the UK, they were told by their insurance company, put SERTEC on your boat. So you have the installation, you have the product cost, but the other cost side is maybe an advantage insurance, and also the factor that you are protected. So, that's a cost as well. The protection safety cost is there as well. So these are, I would say, cost-effective solutions, and Nick from TMS can help you with that.
Question. Anything online?
Yeah, please. Yeah.
You want to shout them out?
Oh, okay. I think I've got them here. I can see them. Yeah, I can see them. Let me just run through them one by one. No sound. Yeah, we got that one fixed. Okay, no sound. Okay, so the question is exactly the same as yours, sir. It is what would be the cost of a 12-meter yacht? Whoever this is, we'll put you in touch with TMS. Jonathan Massey, thank you for your question. We'll put you in touch to give you some price guidelines. Every single boat is different. There is not one flavor that's the same, even if they're the same brand. They all have different aspects to them, so we account that in the pricing.
You know anything about the hedgehog style antennas that are designed to release?
So there are different methods. I didn't focus on any of the other methods today. There's a thing called a dissipation array system. There is these wire brushes. You may have seen them. We very fortunately at Southampton Boat Show, was it 2 years and a bit ago, saw Puffin, the guy that went around the world. I don't even know his story. He nearly died way out in the Pacific or something sea, and his boat sunk and he was saved by a fisherman. But we at least stopped lightning when he was going around the world. So the trouble with these wire brushes is it's not scientifically, I mean, how many wires do you have? So maybe if the voltage was very low, you'd be okay. But when you put it in a laboratory and you step up the voltage, bang, these wires get hit. So normal technologies are called lightning arrestor systems, a wire, and a thing called an early streamer emitter, just been banned in Malaysia, India, America, because it shoots an upstreamer. It electrically makes an upstreamer go up. So those technologies are really, they're there, and it's great that there are people doing things, but when you look at it, it's bringing the strike to you. You don't want that. So our technology does not allow that to happen. A dissipation array system, if you see it on the top of a chimney, is a great big cage. So boat owners want something that looks wonderful and is made well, and our technology on top of a super yacht looks great, especially if you get the gold or diamond one, which we get asked for. So yeah.
Any other questions? What's the benefit meaning?
I'll let my
Any sort of like so we recommend get started like glass. As long as it's 930 centimeters square and then we'll inside the hub.
yeah.
Or the cast iron on 4.5 on the outside of the building. Just allows me to measure.
Yeah, for those online that probably couldn't hear that answer, you can generally use any type of grounding plate, but there's a certain size for it, and we can recommend that. And we have one. If it's a catamaran, it has to be on both hulls. Single hull boat, we put 2, etc.
So we did one application where we've seen the right program and we're actually using existing grounding base where we're comfortable with the current system.
Yeah.
Steve said earlier, every single application is checked by the regulators.
Yeah.
Even though we've got a pretty good idea what's good, we always verify and check.
Yeah.
Because we're protecting life.
Yeah, so just for the people online that can probably hear me better here, if you have an existing earthing, we check all of that on the boat, and we advise you if we can use that existing earthing, or you just need to make a modification.
James has a question about wooden vessel.
Any problem for application to a wooden vessel? No, as long as you've earthed it and you have an earthing plate on the hull.
The only application I see is getting the cable from the unit down to the bus system. That's the only problem we have.
Yeah. So again, for everybody on Zoom, just really as the ability to be able to run the earthing cable down to the hull. And we can look at that for you. If you have an example, please send it through to TMS and we can advise you. Why cannot the keel be used to earth it? Yeah. Yeah, so you have to. Yeah, so we got these paint coatings over it, causes a problem, but we do get around that. So again, we can advise you on that. If you just tell us what you have, we'd advise you the way to achieve the earthing.
I have to say, actually, Steve, I saw the yacht. I think it's a farm a few years ago. I didn't get to see the yacht after being struck by lightning. It had the holes all the way along the hull, just above the waterline, fortunately. And the 2 people who were on it were saved.
Yeah.
They were very, very lucky. But another day, if that had just gone below the waterline, it would have been sickening. Shocking. I mean, the visual appearance of what you're looking at is absolutely shocking. Anyway, Steve, brilliant.
Time for lunch, which is good.
Yeah, absolutely. Thank you.
Thank you very, very much, everybody, for listening. Thank you very much. Thank you.
So to those of you online, it's 1:45 here in the UK. We're going to break until 1:30.